Let us look at proposition number 32 of works of Archimedes, specifically from book 1 of On the Sphere and Cylinder. The proposition says, if a regular polygon with 4n sides be inscribed in a great circle of a sphere, and a similar polygon be described about the great circle, and if the polygons revolve with the great circle about the diameters, so that they describe the surfaces of solid figures inscribed in and circumscribed to the sphere, then the surfaces of the circumscribed and the inscribed figures are to one another in a duplicate ratio of their sides. And the figures themselves, that is their volumes, are in the triplicate ratio of their sides. So let's take it step by step. Given a sphere with an inscribed polygon and a circumscribed polygon about a great circle of the sphere, let AA prime and lowercase a prime be on the same straight line. Join BB prime, MM prime, YY prime, lowercase bb prime and YY prime. They are all going to be parallel to each other. Revolve the great circle and the polygons about AA prime and AA prime to produce the sphere inscribed polygonal solid and the circumscribed polygonal solid. So let me show it to you one by one because one hides the other. So this perfectly forms the given sphere. Now let's remove that and let's look at the polygon. This is the circumscribed polygon. Again, let's remove this. Now let's look at the inscribed polygonal solid. Now remember, the circumscribed polygonal solid is an inscribed polygonal solid in a larger sphere. So let me bring in that larger sphere. Now let R be a circle equal to the surface of the circumscribed solid. So when we say R be a circle equal to, it means let the area of the circle be equal to the area of the surface of the circumscribed solid. Similarly, let S be a circle equal to surface of the inscribed solid. Then in a previous proposition, we have seen that the radius of that circle R square is equal to AB times BB prime plus MM prime plus YY prime. Similarly, radius of S square is equal to lowercase AB times BB prime plus MM prime plus YY prime. Circumscribed solid is similar to inscribed solid, because if the inscribed solid is 8-sided, the circumscribed is also 8-sided. So that means AB times BB prime plus MM prime plus YY prime is to AB times BB prime plus MM prime plus YY prime. Now, look at these not as mathematical expressions. Look at it as a rectangle where AB is one side of the rectangle and this is another side of the rectangle. This is another rectangle with one of the sides as AB and the other side as this. And we know that rectangles are, or most generally, rectilinear figures are in duplicate ratio of their sides, corresponding sides. So we can say AB is to BB prime plus MM prime plus YY prime is to AB times BB prime plus MM prime plus YY prime is equal to AB square is to lowercase AB square. These are nothing but areas equal to the surface of the circumscribed and inscribed solids. So which means surface of circumscribed solid is to surface of inscribed solid is equal to AB square is to lowercase AB square. That is in duplicate ratio of their corresponding sides. Now, let's look at the other aspect of the proposition. That is, the volumes are in triplicate ratio of their corresponding sides. So now take a cone V. I'm not going to draw it because it becomes too large for this one, and it's just a cone. There is nothing else that we are going to be marking on that. Take a cone V whose base is circle R and height is OA. Now, what is this OA? If you look carefully, you might think that it is a radius of the great circle. No, that's not the way to look at it. The way to look at it is that it is the perpendicular distance from the center to the side of the polygon. Of course, in this particular case, what happens? In case of a circumscribed this one, it is equal to the radius of the great circle or radius of the sphere. But strictly speaking, you should think of it as the perpendicular distance from the center to one of the sides of the polygon. Similarly, take a cone whose base is circle S and height is a perpendicular distance from O to AB. So let me hide this perpendicular distance, and now let's look at the other perpendicular distance. That is the perpendicular distance from O to the inscribed polygon's side, and let's call it as P. Because they overlap each other, that is why instead of looking at this line, we are saying, okay, let's treat it as OA, because they both are the radii of the same circle. Volume of cone V is equal to volume of circumscribed solid. Because again, in a previous proposition, we saw that the volume of a circumscribed solid is equal to a cone whose base is equal to the surface of the solid and height is equal to the perpendicular distance. So since that is the case, we can say volume of cone V is equal to volume of the circumscribed solid. Similarly, volume of cone W is equal to volume of inscribed solid. And we know that AB is equal to OA is to P, which is equal to height of cone V is to height of cone W. Since bases of the cones, that is circles, R is to S is equal to AB square is to AB square. Now, how did we get this? Because we have already proved that the surface of the circumscribed solid is to surface of inscribed solid equal to AB square is to AB square. But remember, circle R is equal to surface of circumscribed solid, and circle S is equal to surface of inscribed solid. So since these solids are in the ratio of AB square is to AB square, we can say the circles are in the ratio of AB square is to AB square. So which means that the volume of cone V is to volume of cone W is equal to AB cube is to AB cube. Because the height of cone V is to height of cone W is again equal to AB is to AB. So volume of the circumscribed solid is to volume of inscribed solid is in triplicate ratio of the corresponding sides. Now here, that is why it is very important to make sure that these are regular polygons. That means all the sides are equal, so that which side you take, it doesn't matter. They are all equal to each other. That is proposition number 32 of works of Archimedes, specifically from book 1 of On the Sphere and Cylinder. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it. And if you think somebody else can also benefit from it, please do share. That's it for now.